Happy day guys, this is Pungaviday Kalamegam from Inspiring Imprints. Today we are going to see Python programming, second problem of string problems. This problem I have picked from TCS Code Vita. If you have not subscribed my channel, it's high time that you subscribe so that you can get benefited on several coding solutions that you look forward to. First part to problem solving is comprehension. So first we will have to understand the problem to provide the right solution. So what is this problem? Little Jill jumbled up the order of the letters in our dictionary. Now Jack uses this list to find the smallest lexicographical string that can be made out of this new order. Can you help him? You are given a string P that denotes the new order of the letters in the English dictionary. You need to print the smallest lexicographic string made from the given string yes. So these are the constraints. First you will have to understand that S of the dictionary is going to be 26 because we are going to take the alphabets, all the alphabets in English. So 26 is the length. And if you check on the string that you're going to check in the dictionary, it could be of length anything from 1 to 100, right? Input is you'll have to give the number of test cases, and the second line has P, third line has the string yes. And now you'll have to print the string in the right order. Okay, let's see the test cases. So here for two test inputs, this is P and this is yes. So this is the output. Similarly, you have another test case which has two inputs, P, S, and your output is this. So let me go on how we are going to approach the program. So these are the inputs that we have. So with the input, what we can do is we'll check the dictionary P, okay, and check whether that alphabet is in the input yes. So with that, whichever we encounter first, we are just going to print. So the from the arrows you could see that B was the first thing that got encountered. So B, and then D, and then we had C, and then we have A. A is in the end. Okay, and this is the dictionary. Actually, A, B, C should be the flow, but here since it was jumbled, we are getting the answer as B, D, C, A. Okay, so we'll move on to the first approach. So in the first approach, what we are doing is we are parsing through the characters one by one in P. So since it is only 26, okay, 26 alphabets that we have, we would be parsing through P and getting all the characters that are present in S. Okay, so this we repeat until we go to the end of P. So this is one concept. And so what we are doing here is, as usual, we always create a separate function for doing the task. So getting the input, and then we are invoking the function get lexi string, and with that we initially create a empty string and we pass through the characters of P and check if that character is in S. If it is so, you just keep adding on the function. Okay, so this could be done using a list comprehension also. So when you do the list comprehension, what happens is typically whatever happens in the for loop is what is going to happen in the list comprehension. So never ever think that list comprehension is going to speed up your program. No, it's going to be the same I would strongly advise it's better not to use list comprehensions when you're doing a competitive programming competition. This is an improvement that you could do. See, though there is a constraint that length of S could be more than P, suppose you're having a lesser count of alphabets in S, let's say, as we had the input as A, B, C, D. Okay, so when you're doing that, you are unnecessarily parsing through all the 26 characters when there are characters in S is only 4. So to do a better optimization, to lower down the number of counts of for loop, what we're doing is once you're done with parsing through all the characters in S, just break and come out. You can see, so one test case, and I'm going to give P as whatever I've copied from the document, and then I'm going to give another input which is your S. Oh, so what I'm expecting is rows. Okay, so submit. So I'm just going to the function and checking out each character of P is being checked. So the first character that's getting encountered is R. So R is being placed in the lexi string, and then it moves on till all the characters are encountered, and S and E. Okay, so we are going to check out E. So E is being encountered, and if you see these three characters, these are not necessary to be passed through because we have completed with the rows, which is yes, the alphabets in yes is done. So this is why I said you will have to have a break so that you can break here after the entire S is completed. However, in this program, we are not having that break. So what it does is it goes on for the other three characters and does it. And we have got the output. Okay. Approach to same input P and S is there. What we're doing is instead of checking the alphabets and printing it out, what we're doing is we're going from S to P. Initially it was P to S, here it is S to P, and we are just taking the indexes of the alphabets. So these are the indexes of A, B, C, D. So A is in 25, B is in 14, and so we have it here. What we'll do is sort this in a list, and after sorting, what we'll do is we'll check this index alphabet here. So it's B. So you'll have to print BDCA, the same output. So algorithm is similarly, you get the test cases. For every test case, you'll have to get P and S. And what you'll have to do is take the index of every character of S and put it into P. And then move on, sort it and print it. Okay, this is the second approach wherein we are going to put all the indexes in one list and sort that list and print out all the characters in that particular list. So we are actually having two for loops, and also the sorting will land up in another for loop. Okay, so when you're approaching a problem, when you have two different approaches, check out the time and space complexity and then decide which is the most efficient and give that solution alone. See, for when you're doing this program for a recruitment process, maybe you would win over. But for something like competitive programming contest, definitely this will be a flaw. Okay, so think over it and then do it wisely. And this is why I've given two approaches, so that you can understand a single problem can have more than one solution and you can give the best. And approach wherein you're having a index list which has the indexes of characters of yes in P, and then we are sorting that list and printing out the characters according to that indices. Okay, so let's see, I'm going to give the same input as in the first approach. So it's going to be just one test case, and next input would be the dictionary as such, and next I'm going to check the input ERSO. Okay, so submit. So let's see what happens. So if you see, a list is getting created here, okay, for each of the characters in yes, and then what it is doing is it is sorting that list. This is the sorted list, and next what it does is for every index it goes checks in P the location and character, rather the character, and it prints it. So rows is all done. So both the approaches I've given, you will have to think through which approach is right for the particular situation which you are in and use it. Okay, bye, see you.